Hello everyone. Good morning. This is Kirtana, Assistant Professor, Department of Information Technology at Sandaswamy College of Technology. Today, we are going to see about the most fundamental concept in networking, the OSI model, that is Open System Interconnection Model. The OSI model is a conceptual framework which is used to understand and implement standard protocols. It was developed by International Organization for Standardization, that is ASO, in the 1980s to help diverse communication systems and communicate using standard protocols. This model has 7 distinct layers, each with a specific function, and each layer serves the one above it and is served by the one below it. Let's break down from the bottom up. The first layer is physical layer. This is the lowest layer of OSI model. This is what the picture explained about with streaming and sending cable, then receiving the cable, that is in the physical layer. The second layer is data link layer. The data link layer provides node to node communication. It takes raw data from the physical layer and transforms it into the format free to the next layer. The key functions include framing, that is, framing is grouping bits into the frames. Then MAC addressing uses hardware addresses like MAC addresses to identify devices. Then error detection and correction via checksums as CRC. Flow control and access control in Ethernet. This layer is often divided into two sublayers, that is LLC and MAC. That is, LLC is logical link control. It manages communication and error correction. MAC, that is media access control. It controls how devices on network gain access to the medium. Example, Ethernet Wi-Fi protocols operates in this layer. The third layer is network layer. This layer is all about routing, moving packets from source to destination across multiple networks. It's add logical addressing to data. Unlike the MAC address, which is physical, here we use IP addresses. The main responsibilities of network layer is routing, that is selecting the best path for data. Then logical addressing, assigning IP addresses. Then fragmentation and reassembly of packets, handling congestion and packet switching. Example, IPv6, IPv4, etc. The fourth layer is transport layer. It is the transmission of data between software entities on endpoints to host. The transport layer ensures end-to-end communication between the devices. Its primary job is to ensure the data is delivered accurately and in sequence. The functions are segmentation, that is breaking large data into the smaller packets. The next one, error correction and retransmission. Flow control, that is preventing data overflow. The last one, port addressing, which identifying specific process or services using port numbers. Two main protocols operate here, that is TCP and UDP. TCP is transmission control protocol, which is reliable and connection oriented protocol. The UDP is user datagram protocol, which is faster but connectionless and less reliable. The next layer is session layer. This layer manages sessions and dialogues between two applications. The responsibilities include establishing, maintaining, and terminating sessions, synchronizing data exchange, managing dialogue controls, that is half duplex or full duplex. Think of it like managing a Zoom call when it starts, maintains the connection, and closes when the meeting ends. That is, here the remote procedure call is the main example of session layer. The next layer is presentation layer, which provides general solution to syntax and semantics transmitted data. That is encoding of data on the wire into the intermediate format. That is, it ensures the data is usable format and handling things like data translation, that is converting data formats, encryption and decryption, then compression and decompression, reducing size for transmission. So if you are sending a JPEG image, this layer ensures that the receiver interprets the bits correctly as a JPEG. The seventh layer is the application layer. This is the topmost layer. the one closest to the end user. It provides network services directly to the user applications such as web browser, email, clients, and file transfer tools. The functions are identifying communication partners, resource availability checking, then synchronizing communications. The protocol at this layer includes HTTP, that is for web browsing, FTP for file transfers, then SMTP, IMAP, POP3 for email, then DNS for domain name resolution. Remember, the layers are uh, which helps to network communication functions. It allows for interoperability among different systems and vendors. It breaks down complex networking processes to manageable layers. It guides troubleshooting. You can isolate problems by identifying which layer is failing. Though the OSI model is a theoretical real-world protocols like TCP/IP mapping, then TCP/IP has only 4 layers, but they correspond closely to the OSI layers. Here we came for the conclusion. The OSI model is a foundational concept in networking that structures communication into 7 layers, each with specific responsibilities from the physical transmission of bits to user-facing applications. Understanding these layers gives you a clear map how data travels through the network. In your networking journey, whether you are configuring routers or developing network apps, a solid grasp of the OSI model is essential. Thank you.